do the same for the long-term adequacy correspondence as well. So yeah, if you have any questions, it's easy. The easiest to ask it in the chat. If you have some questions about the presentation itself or to me, then you can always ask it. Feel free to interrupt me. So yeah, Anastasia, can I just take over the presentation? Yeah, maybe it's not the same PPT that you have, but it's, I think, more or less the same. So here it is. I hope you can see it. So yeah, as Anastasia said, we have the content for today like that. First, there are some overview topics, and then we discuss the workflow. And in the meantime, we start with the trial with the first trial in the tool. To let you see how it works. Just it will be a quick overview with it's a click through project. It's an already done project, and you can see how the tool looks like. And then later in the morning, we will have a second trial from a technical point of view, where we discuss the main steps of the workflow regarding data import, the data-driven modeling, the forecasting adjustment, and the reporting from a technical perspective. And then, if we have time, I think we will get to more conceptual topics and do a second iteration of demand forecasting, which I call the second demo, and it will focus on more conceptual aspects of the demand forecasting. And then in the end, there will be some time for general issues and maybe some recommendations and also a Q&A. But I think Q&A sessions can be done during the training. So if you have a question, you can interrupt me. I'm maybe not see the hands raised, so just please interrupt me. And then after each iteration in the tool, I think we can have a short Q&A if we have some questions that you have. So let's start with the overview.
I will let you also know about the questions. So.
Yeah, okay. Thank you. Okay. So so demand forecasting toolbox. This is the name. This was developed by SIA Partners for ENTSO-E. You have access to this tool. Hopefully, everybody has access right now. In the meantime, I think you can try it. If you have any problems, you can write to Anastasia directly.
I'm providing you access now, so if you have issues in logging in, let us know.
Yeah. And regarding access, there is also one more information. Users now can only see their own market nodes. Depending on the DSO, on the country, it can be more market nodes, more than one market nodes, but generally it's just one. But this may change in the future. So this tool is not final. There will be minor and major developments, I think, in a short period of time and in the longer run as well. So there are some features which will change, which maybe I talk about it right now, but this will not be the case at a later point. So So just keep it in mind that this is not a final tool, but it's a stable tool, so we can do the forecasting with this, and hopefully during the training as well. So this feature is a feature which can change in the future. There were some requests about it, but we will have to discuss. Also, the structure is quite important. So in the tool, you can create projects, and I think it's preferable to have separate projects for each data collection or each study. So the next data collection will be the winter outlook data collection for short-term adequacy correspondence. And this has a deadline, late summer. Please, Anastasia, correct me if I'm not correct, but during the summer we have to make this data collection, and we have to create the demand forecast for that, and this will be the responsibility of the SACs after this training. So
sorry to interrupt you. Indeed,
yeah.
I can confirm that this data collection for demand, it will take place during the month of July. So during this period of the workshops, the DSOs that have registered in the specific workshop, each one of them is going to run the tool by giving the input data that are required to run the tool and produce the time series. Of course, we'll be by your side and monitor the whole process.
Yes, thank you. Yeah, so it will be in July. So yeah, this will be the first project which you have to do, or you are required to do. So yeah, about the structure inside the project, we can have models and forecasts for multiple scenarios, market nodes, target years, or climate years. So you will see that inside a project you are kind of free to expand the scope of your project, of your study, but it will be natural if you are already familiar with the tool. Yeah, and there are some details about how you can create a project and how already trained models can be reused inside projects. So inside one project, you can always reuse a previous model which you already fit, but it's not recommended to have models forecasts across projects. So for each project, which is normally goes with the data collections, for each project you should create a new blank model and demand forecast, and then if you need to adjust it somehow, you can iterate by reusing already final steps. But you will see it if we are in the tool. Yeah, this is the last part about flexibility is what I talked about right now. It's just so you have flexibility inside the tool, and you can create lots of different versions of the models and lots of different forecasts for a given study. But there are some exceptions which cannot be changed right now. We will talk about it later also. But these are some of the files, some of the features, some of the hyperparameters, and some of the algorithm, and the algorithm itself inside the tool. So just to sum it up, this slide, this tool, this demand forecasting toolbox is a quite flexible toolbox for demand forecasting, but there are some recommendations which we should follow, and there are some restrictions which we cannot change. So it's a tool. It's not magic. We should have to keep in mind. So it gives us a forecast for the inputs which we give it to. So this is, I think it's an important thing to keep in mind, that it's not a magic tool. It's just a tool, but it works and it's a stable tool. So about the input files, you may have already heard about this. These files, you already have had to provide them, most of them, to the ENTSO-E during previous demand forecasting data collections. So there is the load file, the PECD files, the calendar file, and the PMDB file. Each file has a different purpose, but all of these files are inputs in the tool. So we have to keep in mind that we need these files ready for the tool to work properly and to be able to create the forecasts. We have some templates for these files, which are helpful, uh, uh, so that you can always use them as a blank template for your market node, and then later on you fill them out and use them in the tool. So the space for these templates, I think it's not final right now, but as soon as you will have to do the winter outlook demand forecasting, we will communicate its latest space to you. Also, in the PMDB file, there are some default profiles for heating, cooling, electric vehicles, which are also helpful for you, which can be found in a dedicated space, but it's not final also. But we will also communicate it to you once we have a final space for them. So this table, I think it's quite important. It shows you the structure and the purpose of the inputs of the demand forecasting toolbox. And there are some information in this table which are not yet finalized, but you will be informed about it later. But yeah, so we will talk about the structure of the files and the content of the files as well at a later point in the presentation. And finally, about the overview. So this is a schematic figure of the demand forecasting toolbox and the demand forecasting process itself. So outside in the boxes, you have the inputs. You can see the PECD files, the historical load and calendar data. Under that, the PMDB file and the target demand values. And these are the inputs for the demand forecasting process. And you can see that these inputs affect the data-driven model and the physics-aware model, which is the upper part of this workflow. This is we call the physics-aware model, which we use for the forecast adjustments. So after creating a model based on historical load, which we call the data-driven model, we forecast the demand and then adjust the demand based on the physics-aware model. And then at the final step, we get a total forecast for the demand, which we can further rescale, further adjust based on target demand values, which are also inputs. So I hope this figure is understandable. So this is the basis of the DFT and the whole process. And again, we will talk about all the details, all the parts at a later point in details, but this is just a quick overview, for you about how it works. So now, after the overview, if you have some questions, feel free to ask. And in the meantime, I'm going to share my screen or change my screen and log into the demand forecasting toolbox and show you a quick trial how the toolbox and the interface works and looks like. So let me share.
We have some questions from Michalis, but I think all of them are going to be answered later in the presentation.
So you in the chat, you mean?
Yes.
Yeah, okay. Yeah, thank you. So this is the URL of the demand forecasting toolbox. If you have access, you can then log into the tool. And then at the first glance, you will see a project dashboard. This shows all the projects, all the previous projects of you, what you created and what you have done. You can see that there are some from my side. But for now, for the first trial, I will not create a new project. I will just click through a previous project and we can see how the tool looks like and how the process itself looks like. So after you click on a project, you will see the details of these projects. There are some details which you have to give once you start a new project. So it's the name, the creation date, the organization, and you have to give a short description about this specific project. And the next part is import. At this stage, you will have to import all the files which you need for the project, for the demand forecast to work. And you can see that it's already loaded. You can import, you can select here the market node, select a scenario. You can import calendar data and the PMDB data here. And once you uploaded them to the tool, you can have a first look at the input data. This is the historical load time series. And these are the PECD files. You can see that there are 4 of them: wind speed, temperature, irradiance, and another temperature. So you can change and inspect the time series of these data. And then the calendar file is also imported. So you can see how the special days are grouped for this node, for the Hungarian node. And you can inspect if you see some problems here, which you don't want to see, then you can change the input data and then start over the import section. So once you checked all the data, you can go to modeling. This is called data-driven modeling. At this step, you can create a model for the historical time series, which will serve as a basis for the forecasting. So this is data driven. This means that this learns the the association, the relationship between the historical load and the features that you want to select. These are uh, weather features and calendar features, and you can have some other adjustments of the model uh, uh, to have the best result you can get. So this is the interface for this model building step. You can see that you can choose the model type, other parameters. You can choose the weather features, the calendar features which you want to use, and you have some advanced parameters related to the model type. And then if you are final, you're ready, you can click on this button and the tool will do the modeling. So it will learn the relationship between the historical time series and the selected features. And then after it finishes, you can see the results of this modeling step. So you will have some plots that you can inspect, and you will already have a basic forecast of the load, uh, which you can visually inspect, and you can also inspect how well the forecast behaves. And if you are not satisfied with the results, you can go back to the beginning of the modeling and start over with a different parameterization or different set of features, and then you arrive at this stage where all the models which you fitted will be listed here, and you can select from this list one data-driven model, which you will use for the next step, for the forecasting step. So this model which you select here will be used for the load forecasting. So in the load forecasting step, which looks like this in the interface, you will have some uh, parameters to select. So you have to select the forecast time period. So which target year you want to create a forecast. So maybe it's good to mention here that in the DFT right now, you can only create demand forecasts for a whole year. So we are talking about target years here. So for instance, for the winter outlook, the next winter outlook, um, winter is over is in 2023 and 2024. So you will have to create. So it's recommended to create a forecast for two target years, 2023 and 2024 here, and then you will only select the periods which are in the winter outlook period. But we will discuss it later at a later point in during the training. But this is how you have to select the forecast time. This is the target year. Also, you can select here the climatic years, which you are already familiar with, I think. So the concept of climate years. So this is the selection of historic years which are in the PECD database, and then these years will be used for the forecast, and for all these climate years we will create a different forecast based on the different weather conditions that were present in that climate year. You can also select the calendar here. So you select what kind of calendar you want to use. It can be selected that it should be the same as the forecasted year. So for every forecast year, which is listed here, it can be selected that the tool use the same calendar year. So this will be required in the winter outlook, but for longer term demand forecasts, it's not required. So you can select a specific calendar year. It's usually 2018 because of practical reasons, but for the time being, I think it's enough to remember that we should use the same as forecasted year option here for the winter outlook forecasting. Also, there are some other options here which are rescaling options, which we will talk about later a lot, but you can also select them here. And after you select all the parameters here, you click on validate and the tool reads all the information and summarizes for you here under this section. And you will see all the values that will be used to forecast the load time series for the given target year. If in case you are satisfied with the preliminary data here, you can click on run forecasting, and it will take some time. If you have some more than 1 year and more than one climate year, it will take some time, but it will create all the forecasts that you need. So this is the forecasting step, which also contains the forecasting adjustment step and the rescaling step. We will talk about it later, but this is not just forecasting. This is also the adjustment of the forecasts and the rescaling of the forecasts at this step. And finally, there is a section called results, which contain the reports, which you can download and check in the tool as well. There are some quick reports for the given scenario, for the given forecasted year, and you can have a quick overview of the forecast right in the tool. This has some KPIs which are implemented in the tool. You can check them, and if you are satisfied, you can go on and download all the reports that you will need. We will talk about the reports as well. And yeah, there are some visual inspection possibilities here as well, how the forecast looks like, what are the main components of this forecast, and also there is the temperature dependency plot, which just plots the forecasted load versus the population weighted temperature. So these are all for inspecting the results, and in case you are fine with the results, you can download the reports, and that's where the process ends, the process finishes. So this, I wanted to just show you an already created project, an already finalized project in the tool, just to have an overview how the tool looks like and what kind of steps you have to take inside the tool. And these steps are also the workflow, which we will talk about it next in the presentation. So I change back to the presentation right now. Any questions? If not, I can go on. So about the workflows, as you could see in the previous demonstration, there are 4 main steps of the workflow. This is the importing of the input files, the data-driven modeling, the forecasting, and the reporting finally. So this is just a quick technical overview of the workflow. This can be more detailed, and there can be iterations if you have any kind of so if you're not satisfied with the results, or if the results are not quite good, you can, or you have to iterate on each of the steps until you get a final forecast. So yeah, this just as a technical question, the technical issue. So I just labeled all the slides here. So at this point, I will go through the technical labeled slides. So just to get an overview of the technical aspects of the tool. And then later on, we get back to the conceptual issues as well, and the slides as well. So about data import. So as we already saw, the data import section has first has two options to select. At first, you can select the market node which you want to analyze. So as I already mentioned, this market node is, so for every user there is only one market node, or there are some exceptions, but the main rule is that you can only see your own market node. But in case you have the possibility already to see more than one market node, this is also important that the DFT produces independent models for each market node, which you select here. This is just if you select more than one market node, you can create the same model for all the market nodes. I mean, the same type of model for all the market nodes, and this just makes the process easier. The other thing is the scenario which you have to select. There will be a list which you will see here, but and you have to select one of the scenarios listed here. This is quite, I don't know, it's not that important to follow or to have a scenario which is the same as the data collection which you run the forecast for. So it's not a really not a really important topic what kind of scenario you select, but it's recommended that for every you will see it later, for every data collection you name the scenario, you name the files, and especially it will be the PMDB file. You name the PMDB file based on the scenario, based on the data collection or the study which you create the forecast for. It's more complicated than it is. It sounds more complicated than it is. It's just, you have to select a scenario here, and then later on, you just go on with the process and get the results back. But it's good to keep in mind that for every data collection, you should have a certain scenario, and you have to be able to pair them. For one data collection, a specific scenario which is required. Yeah, okay. So it's not that complicated, it just sounds complicated, sorry for that. But yeah, the next section in the import section is the input files. You already saw in the tool that you can import the calendar data here and the PMDB data here. I guess you already a bit of familiar with all these files, but we will talk about it later, how they look like, what are the key requirements for these files. So, but yeah, in the interface, it looks like here, you can select for all the input files, either a database file, which is already in the database of the DFT, or you can custom upload a file from your computer. Yeah, this custom upload is important and is useful because you either want to perform kind of sensitivity analysis, or you detect some errors in the files, in the default files, which are in the database already. And you, in case of that, you may want to change the files and use another one. So you can always create files for your own. And as I already mentioned, there will be templates for you to fill in and use them in the tool. So after you selected or imported the files, you are able to visualize the input files in the tool. As you already saw, the historical load data, which is not right now not recommended, not possible to upload, but this is in the database of the DFT. So you can check it visually, the time series of the historical load data, and you can also check the time series of the PCD climate data, how they look like. So these data are not, you are not able to change right now. So in case you have a problem with these files, with these data, after you visually check them, you can send an email to Anastasia and send a new load file. And if in case you send it, she is able to change that file in the database. This is also, this sounds really inflexible, but it will change in the future as well. So at this point, these data cannot be changed by the user, but at a later point, this will be an option for you as well to have a custom upload for the load data and maybe for climate data. But climate data is PECD data, which is provided by ENTSO-E, provided to ENTSO-E and provided by ENTSO-E to the DFT. So this will not be the case for PECD, I think. But for historical load data, it will be a feature in the short run of DFT. And then there is the calendar data, which you can inspect here visually in the import section of the tool. So as I already mentioned, you have this calendar here, and you can it will visualize for you the special days, which are indicated as special days in the calendar file, which you import. So if any errors you detect in the file or here in the calendar, you can change the calendar file accordingly and use another calendar file, calendar data, for the modeling. So this is the import section part. And I think right now I will start a new project where we see all these steps as we go on with the presentation. So I clicked on the create new project button, and then I have to give this project a title, DFT training trial 2. So I can change, or I can choose an organization, but it's just Mavir, the Hungarian TSO for me. And there are some studies which are already present here. You have to change, you have to select here something, but it's also not that important. It's maybe just for you to be able to um, keep up with the previous project, and you can in the list you will see after some months as well which project you created for which study or data collection. I think, Anastasia, again, correct me if I'm wrong, so this list is created by is maintained by ENTSO-E. So for winter outlook, for the next winter outlook, there will be an entry here saying winter outlook 23, 24 maybe, and you will be able to select it once you create the final winter outlook demand forecast. Is it correct, Anastasia?
Yes, I can confirm. We will add the winter outlook there with the help of our developers.
Yeah, it's developer stuff, but yeah, it's maybe it's easiest to it's best to have a winter outlook project here or study here. So, but
Yes,
for the
yes,
time
we will
being,
add that.
for the time being, I select test and I just give a description, which is also you can give anything you want, and then you create the project and you can check the summary of the project, and you right away can go to import. And we can just go through the steps which we talked about in the previous part of the presentation. So I select the market node which I have, and I can select the scenario. This is the same as the study part, more or less the same. It's not that important to select here a scenario which is a valid scenario, but yeah, you will see how you can at a later point modify the scenarios here. So I just select now national trends scenario, and then I click on validate, and then right away I get to this import section where I can see the calendar data options and the PMDB data options. So I can choose data from the database, and I can choose data from a custom upload from my computer. And these buttons are called the download buttons for calendar template and download button for PMDB template. If you click on it, you will get a template for either the calendar or the PMDB file, which you will be able to modify for your own needs. And with the custom upload it once you are ready filling it out. So right now, I just click on, I think, load to get data from the database. These are files which are already available for the tool from previous data collections. And this will take some time for the tool to load, but after it loads, I am able to visualize the inputs and inspect if I see something unsatisfying. But in case I'm satisfied with the inputs, I can go on to the modeling part. So the loading is just being finished right now. And then I can inspect this the data. So this is the Hungarian load time series. It's important, maybe, yeah, to mention here that for technical reasons, the plot here only shows 1 point for 1 day, but it's an interactive plot, so you can always zoom into a specific part. But here you can see that for the January the 1st, 2016, there is only one data point, which is shown here. This is because of performance issues. If the developers of if the tool showed uh, a data point for every hour, then the performance of the tool would slow down a bit. So this is only one data point for one day, and this is, I think it was confirmed by the developers that this is the daily average of the load, historical load for this specific day. If you click on reset zoom, you go back to the original time series, and then for each chart there is an option button here which you can use for downloading either the figure itself or the data behind these figures. I will just want to check if the data here contains all the data for all the hours and not just the days. And yeah, this is true. So no, this is not true. So for the input file, this is just one data point for one day. So you get back, after downloading, you get back what you see in the tool, the daily average load, historical load for this given market node. Yeah, and this is the same for climate data, for the PCD data. So you can visually inspect all the weather data which are inputted in the DFT database. And if you see something strange, you can ask for modification, or you just discuss it with Anastasia but normally these are PCD files which are created for each DSO, for each market node. So this is the data. This is this normally works and doesn't need to change. And finally, the calendar data, which we talked about it, you can visually inspect it here. And if you are satisfied with the inputs, you can go to the modeling phase. In the modeling phase, you can select the training period here. But yeah, first of all, I get back to the presentation. Sorry for that. So because we finished here, so this next step is the modeling, the data-driven modeling part of the whole process. So as a first input, you select the training period and the test period for the data-driven modeling. Maybe these terms need to be defined. So the definition of the training period is this is a sample which will be used to estimate the model and the forecasting functions. So the forecasting function here means actually the model itself. So, oh, I'm sorry. I have some problems with the, yeah. So, so the training period will be used to estimate the model, the parameters of the model, and this estimation, this algorithm minimizes the errors between the real and the estimated demand, and the training period will be used for this algorithm, for this minimization algorithm. The test period is a period which is not used during the estimation, but this this test period will be used for evaluating the forecast, the performance of the model. So this means that already with the historical time series, you not only train the model, but you can already evaluate the model on historical data. So this test period serves as as a sample of the historical load which you evaluate the model on. So yeah, this is written down here. The DFT will forecast the load for this test period, and the forecasted load and the historical load in this test period can be compared, and you can evaluate it with objective KPIs, and you can also visualize it uh, to get a sense of how the model performs on the test period on a sample which the model didn't see actually. So this mimics the forecasting task itself. We will have some more technical parts here. So how this data-driven modeling looks like. So after selecting the training and test period, you have to select the model. You can create more than one model actually to estimate the load and to use these models to forecast the load. So in the tool, it is available. It is an option to use more than one models at once. So it's also makes the process easier. So after modeling with more than one model, you can already compare the models and compare their performance on the test period. There is also one more important note here. You can create a model from scratch, or you can choose from a set of predefined models. These predefined models are either defined by or created by the developers of the tool as a default model, or you will be able to access here the previous models that you already built. I think even for different projects. So if during a project you save a model with the settings, with the parameters, you will be able to access this model at a later point in a later different project. So this also makes the process easier. So if you have a well-working model after for a given data collection, in a new data collection, in a new project, you don't need to create that model again. You just import the values of the parameters of this model, and you can use it right away. So how you create a new model? You have to have a name for that. This is, maybe you are not able to see it, but this is the create new model option. Yeah, and you have to name it, and you have to select some features of this model. So this will be the type of the model, and there are some other options which we'll talk about later. And then you can see what type of models you have in the tool. So in the beginning of the presentation, I told you that the DFT is a toolbox which is quite flexible, but there are some limitations. Uh, there are some strict parts of this model, of this toolbox. So it's not a magical toolbox, but it has some features, characteristics. So one of this is you can only choose four types of models. This is linear regression and lasso regression, and random forest and GAM, which is the uh, generalized additive models. So the first two is linear regression. You will have a linear relationship between the between the features and the load, historical load. And the last two are more flexible models, and they will make it possible to create more mm, more flexible models for the historical load, non-linear and non-parametric models. Uh, we will talk about it a bit more at a later step, but for now it's enough, I think, to keep in mind that we have four of these options, and usually the GAM is the best, I think, which is the best because it is flexible enough, but still uh, uh, understandable enough for our purposes. So I think the GAM model is which is the most used by us, by the demand expert team, and also this is recommended by the developers as well. So yeah, there is still some more technical aspects of this data driven modeling part of the tool. So you can select between two options. You can select the so-called hourly models, or you can select the hour feature as an explanatory variable. So if you choose, this is a radio button, so you can choose either of one of the two. So if you choose the hourly model option, which is called model per hour option in the tool, so if it's turned on, the DFT will estimate 24 different models for each hour of the day across the whole training period. So there will be 24 different models, and these models will be not linked to each other. They will be estimated separately. This is one option. And the other option is when the model per hour option is turned off, the DFT will estimate only one model for the whole training period. But if we would like to have the hour feature as an explanatory variable in the model, we can choose it, but it will have a bit different um, uh, result for the effect for the results. So this is an option which is we should keep in mind what we would like to do, or we should get to know a bit how our time series, our data behaves and what we want to do. There is a suggestion by the developers that we should use the model per hour option turned on, but because it will give you a better performance. But this performance is a performance which is evaluated in the short run, which is good for our purposes now for the winter outlook period, but it may not be good for other purposes, for longer term models, or even for this short-term adequacy task, the winter outlook. It's not. So you have to decide, but we will talk about it later on what kind of from which aspect you should decide about this option. But this is a technical slide because you have to choose one of them, either the model per hour option turned on or turned off. And this means what I just talked about. There is another option in the tool which you can select. So this is about the confidence interval. The confidence interval means that the tool will create a range around the forecast based on this value. So it will calculate higher and lower, or upper and lower confidence level of this of the forecast based on this value. Yeah, there is a maximum value for this confidence interval parameter and the minimum value. So, for instance, the maximum value will mean that at the forecast step, you not only get the mean or the predicted mean value of the forecast, but also the estimated lower 10th percentile of the forecast and the upper 90th percentile of the forecast. So it will give you a range of the forecast, not just a point value. Yeah, and for the data-driven modeling to work, to finalize, you have to select the features, the so-called regressors in the tool. These are the weather features and the calendar features. And you can see how you can choose them. We will do it right away in the tool. And if you, in case you select something, the model will use it as a feature in the data-driven model. And finally, we have some advanced parameters. Once you select a model type, which we talked about it was the two types of regressions, the GAM and the random forest. You have to select hyperparameters as well. So for the GAM model, you have to select the number of splines for the features that you selected. And for the random forest, you have to select the number of estimators and the number of the maximum depths of the tree of the random forest algorithm. So these hyperparameters are for fine-tuning the data-driven model, but as a first technical overview, you just have to keep in mind that you have to write a number for each of these parameters, and this can be done. I mean, by just selecting any number which you want, and then after you inspect and the results, you can come back to here and fine tune the algorithms with different values for these hyperparameters. So this slide is a conceptual slide as well, so we will get back to it and we will talk about it a bit more in the next iteration. And once you selected all the inputs for the data-driven modeling and also the parameters, the DFT will create the model, estimate the parameters, and then you can see in the interface a result section where you can assess the results of the model. So the first panel will be um, these partial dependence plots. With these plots, you can assess the effect of a feature on the demand. So any feature you select in the previous section will show up here, and you can visually check the relative effect or the relative relationship, the relationship of this feature between this feature and the historical load. If you will have more than one model, each of the model's partial dependence plots can be compared here. So this is a feature of the tool to assess the results. And yeah, there is not the results, not the forecast itself, but the model itself and how well the model captures the relationship between a certain feature and the load. Also, at this point, you are able to see um, the estimated load from the model. In the first plot, or the upper plot, you will see the actual time series as black, as the black curve, and the fitted time series as the fitted and the orange time series as the fitted curve. So you can visually check how the model performs on the training and the test period. The training period will be separated from the test period with this vertical line here. So the model is estimated and fitted on the training sample from the left to the left of the vertical line, and to the right of the vertical line there is the test sample, which is used for forecasting only. It's not used for the training, for the estimation of the model, but you can also already see here how the model performs on a sample which it didn't see previously. The residuals in the bottom plot, these are the residuals, the difference between the actual and the predicted load time series. These are also plotted here. So if you can inspect any structural or systematic problems, then it shows you that there is some problems with your model at some parts of the historical load time series. For you, for this example, I created a model which has some problems for the year of 2014. So the model for all of this year over predicts the load. So the actual load was lower than that. So this is a systematic problem which should be somehow corrected. In case you see something like this, yeah, it's preferable to go back and inspect the historical load, why this year behaves maybe differently from the previous years or for all the other years, or there is some problem with the model you estimated. So these plots are for visual inspection of the performance of the model. And then you will have some other types of plots still for visual inspection. So the first one is the weekly average errors for the test period. So you cannot see it, but you will see it in the tool. So for every day of the week, there is an average error of the model. So this is the average difference of the average difference of the actual and the fitted curve. But I will check it. For the test set, just wanted to make sure that this is the test set. So this is for only the test period. So you can see how the model performs on a daily basis, which days are overestimated or underestimated. This plot shows that for every types of weekday of every day type, the orange is the the forecasted load. So yes, this should be minus. So for for the test period, the model underestimates the actual load. So for this plot also, it shows that for every day type, there is an underestimation, and the average underestimation for Monday is higher, or is, I don't know how much. It's 300 megawatts on average, and it's higher than for an average Saturday and Sunday maybe. And this is the same for for a monthly average errors. So you can inspect how the errors are distributed among the year. This shows the same story. The forecast is underestimates the real load, so you can see a negative value here for every month. And the last panel of the results in the data-driven modeling section shows a summary of the models which you fitted. So for this example, it shows 2 different models which I fit for a different project. And there is the model name here and some other model parameters, the type of model which I chose and the type of regressors which I used for this specific model. And then from this column, the RMSE CV column, to the right, there will be objective KPIs which evaluate the performance of the models which you created on either the test period or the training period, or there is another option, the CV error, which we will talk about later. But so these are kind of objective KPIs which can be used to assess the performance and to compare more than one models. For this RMSE, the lower the better. So I guess the second model will be selected based on this criteria, but it's suggested that you check all the criteria, or you check the criteria which you are familiar with or which you like, and you you decide on which model you want to choose based on these criteria. So so yeah, these are called the goodness of fit measures. And in case you are able to select one model, because you're satisfied with one model, you have to click on the select option, and then you are ready to forecast the load, the demand or the load um, for the selected target here, and with some selected features which we will talk about later. But data-driven modeling ends here after selecting one model which you will use for the forecasting. So as you can see, there will be some other conceptual slides here. Many of them will be more conceptual, but for data-driven modeling, this is the last step, and then you will be able to do the forecasting in the tool. So I don't know if you have any questions right now. I think I'm not sure how we are with the time, but yeah, we should maybe do this whole process, this technical process at once, and then we can have a short break, I think around 11, if that's okay.
Yeah, we can do it like this if you want. There are some questions in the chat.
Yeah.
So one that I can see from Michalis. What
Okay,
was the difference between the two models? The slides.
So this last slide, you mean, when I compared these two models, right?
I think so, yes.
So this was only done for, I mean, for an example, but yeah, we can briefly talk about the difference of these models. Yeah, maybe you already checked it, but yeah, the difference that you can see here is the set of regressors which I used. So for the first one, I used all the PACD climate features: wind speed, irradiance, population weighted temperature, and population weighted smooth temperature. But in the second model, I only used 3 of them. I didn't select the plain population weighted temperature. I did it because these two features are really similar. Smooth temperature is just a smooth average of the raw time series. So I don't really want this information to be uh, mm, twice in the tool, to be present in the model twice. So I just wanted to select one of them. And then there is a difference between the calendar features as well. So so yeah, there were some different types of uh, special days. So I chose different set of special days to be um, used as a feature. But there can be some other differences between the tools, between the models, because there were lots of parameters even for GAM. So these are all, both of them are GAM models, but for GAMs, which we already saw that we can use this advanced parameters part to to tell the model, to tell the tool, to tell the model um, how flexible it should be. So if we choose more splines for each of the features, we will get a more flexible interpolation, let's say interpolation of the relationship. So if we choose lots of splines for one feature, we can get a very not a straight line, but a very flexible line. If you choose less number of splines for each feature, we will have more a relationship which is more close to a linear relationship for a specific feature and the load. But we will talk about it later. I just wanted to show it to you that at this stage, where was it? So at this point, you basically select the models based on their performances at this point, but you don't really have a whole summary of the different aspects of different features of the models. So you have to maybe remember it, how you fitted each of the models, but I think it's not that important. So in the workflow, you will create models based on different features, based on different parameters, hyperparameters, and then at this list, you will be able to see the performance of these models. And I think it will be easy to, it's not always easy, but you at this point you will be able to select one of them based on these goodness of fit measures. So yeah, this was maybe the question. So these are different models, but these can be different from each other from more than these characteristics. But at this point, the tool wants you to select a model, and these are done by comparing the goodness of fit measures. Any other questions? Yeah, I don't know which one was the next one. Can you help me, Anastasia, maybe?
Yes, so if you scroll down a bit, yeah.
Oh yeah, there are lots of questions.
No, a bit lower. So, and even lower, yeah.
Yeah, these will be answered at a later point. Yeah. Weird calendar files. Okay. Yeah, I think we will cover them later, I guess. Yeah. Yeah, this one.
Yeah, this is
Will
where
give
we
us
were.
default settings. Yeah, I talked about default settings already, I think. So in the tool there are default settings right now. You will see it in a minute, I think. I don't really know how to play. Yes, true. This is why we asked the developers, or ENTSO-E asked the developers to have some default settings as well. And this is why I also do this first iteration as a technical iteration. So I don't want to get into details about all the conceptual issues, but I just would like to have you a sense of the tool and how you can just manage to create a forecast at a quick pace.
Actually,
Yes.
while you will be creating your model, you will have some recommended models in the list, and the automatically best fitting model is the one that we usually go with. And these are and of course, when you select a model that is already in the list, it has default values, which in case you would like to experiment a bit, you can change and adapt to your needs or thinking. But of course, there are default values.
Yeah, so I think maybe it's time to do the data-driven modeling in the tool. So yeah, I just start with the training period and the test period selection. For certain reasons, I only select training period for 3 years. Yeah, there is one rule that the training period should be earlier than the test period. I think maybe it's not even possible to select an earlier test period than the training period, but these are time series, so we should be able to forecast ahead of time. So the test period should be after the training period. So now I select 3 years for the training period and 1 year, 2019, for the test period. And I click on validate. And I have the option to create a new model for this Hungarian node. So I create a new model button. I click on the new model button. And yeah, right now you can see that this is loading. So I'm able to create a new model or import an existing model. And this is for me, a long list already, because I experimented with the tool. I use some models for my own purposes, but I think for new users as well, there will be at least one or maybe more than one, but this automatically fitted best model, which Anastasia just mentioned, will be available for everybody, or should be available for everybody. This is a model which was created by the developers as a default. So if you select it, yeah, you can see the basic characteristic of this model. So this is a GAM model, and this has the following features. And if I click on select, I can even modify it for my own needs. So I can modify the name as well. But for now, for the time being, I just import it as it is, because I would like to see how this default model behaves. And then the default model has the parameters which you can see here. So it's a GAN model. It's a model per hour model. So this will, once again, this will create 24 separate models for each of the hours of the day. And then the confidence interval is set to 90%. And these are the weather features which are selected. These are the calendar features which are selected. You can see this number of splines. It's set for every feature, calendar feature and weather feature. So this is the 10 number of splines. 10 splines is quite high. So it will be a really flexible model. So this means that the model can be fit quite quite exactly to the historical time series. So to the training period, it will be fit quite well. But we will see how it will perform on the test period. So hopefully it will not only fit the training period well, but the test period as well, which the model doesn't see during estimation. So if I'm satisfied with these settings, I can run modeling. So it will take some time. And you can see the progress bar here. So this has a message as well. So after the modeling task has run successfully, please make sure to select a model by market node to be able to create the forecast. So it says the forecasting task will fail. So you have to select one model at down in the bottom of the tool to be able to go on to forecasting. This is just a message for that. So I think in the meantime we can answer some questions. You lost me. So we are able to we can select an existing model. This is what I just did. So this automatically fitted best model was a default model, which is, I think, which should be available for every user, even for new users. If it's not the case, you should contact Anastasia, I think, and this will be a developer issue, so we will forward it to the developers, and they will make it available for every user.
Indeed, yes. I have just answered to the question. So there's a follow-up of why are we inputting data to the list? So indeed, the PMDB file will be, I'm not sure if this has already been implemented by the developers, but we will be able to upload the PMDB file in the forecasting step and not in the modeling, in the import step. But the calendar file will still be imported then, because this is what the training and the testing period depends on. So this is why we imported earlier.
Yeah, so this default model is just a model. This builds upon the input data you input. So this you should imagine it as a different entity in the workflow. So this is a separate. This is a model. This is an object. This is a model. So it works on actually on. It can work on different inputs as well. So for every project, you should input different data. Of course, there are some limitations for this to work. So you have to have so yeah, I can show it to you. So here there are calendar features, which I called date type A, date type B, date type C, date type D. So in the calendar file, you have to have these columns as special days to this in order to this model to work on your inputs. So yeah, this is a default model, but it works on different inputs as well. And as Anastasia said, in the input section, in the input section right now, you can upload the calendar file and the PMDB file. The calendar file is used at this step of the process, I mean, for the data-driven modeling, but the PMDB file is used for the adjustment of the forecast. So it's used in the forecasting step. And that's why at a later stage of the toolbox, the input or the importing of the PMDB file will be moved to this section because it's related to forecasting. So yeah, this is what Anastasia said, that right now you import it in the import section, but it will be later moved to this section. But still, in the tool for every project, you will have to do the importing step as well. Right now, this is the calendar files which you can customize, and at a later point it will be the load file as well, the load time series as well. And yeah, this will be a step in the workflow which will require you to decide. But as you saw, there are data in the database already. So if you don't want to change it, you just click on accepting, or I don't know, importing, and then using the files from the database. So you don't need to adjust anything in the tool if you are satisfied with the files in the database. And yeah, what the question was about, so the data-driven modeling, so you can choose an existing model, and the existing model is defined by these parameters. So if the inputs are the same, yeah, this model will be, I mean, the structure of the inputs are the same. This model will work on the new inputs as well. So yeah, I hope I could answer the question. So as we saw in the presentation, after running the modeling task, you are able to see the results of this model. First of all, there are the dependence plot, partial dependence plots for each regressor and for each hour. So remember, we chose an hourly model, so we have a model for each hour. We have a separate model for each hour of the day. So that's why in the partial dependence plots, we are able to see different plots for each regressor and for each day of each hour of the day. Next, you will see the results after some loading. No, sorry. Yeah, maybe I will just change it to be able to see. So this is the visual inspection, of the prediction. So you see the training period and the test period. So now the fit is quite okay, looks okay. We see the the residuals. There is not much systematic errors, but there we have some problematic days and also a problematic period as well for some reason. But the training period and the test period doesn't look very different. So the model was able to fit the model on the training sample, but it doesn't really, it looks like it doesn't fail in the test period, so it can forecast, at least from a visual inspection. Now you see the average errors for the day type of days. It's not, it's heterogeneous, so, and it's close to zero, so it's a better model than we saw in the presentation. And also this is the same for the months, the type of months. Of course, yeah, there are some problems, more major problems in January and in November, and also at the end of the summer period. So we may be able to have a better model for our time series, but this is how you inspect and where you inspect the results visually. And then for a more objective inspection of the performance, you are able to check the fitness, the goodness of fit measures. You can see that there are lots of more than one goodness of fit measures. We have RMSE, 3 types of RMSE, 3 types of MAPE, and maybe and 3 types of MAPE 3P. We will talk about these KPIs at a later point, but for all of them, these tell us anything, I think, if we compare it to other models. So, but I don't know, maybe I don't know whether we should create a new model to be able to compare the models, but I think for the time constraint, we will have time for that as well. But to keep the 11-hour break, I think I just go on with this model, select it. It says model successfully selected, and then I can go to forecasting. So this was the data-driven modeling part. Now I have a model on the historical data, which I already evaluated, not just on the training period, but also on the test period. So I have a sense of how this model can forecast, how the performance of the forecast, what is the performance of the forecast of this model. Now I can go on and actually do the forecasting. So in order to do the forecasting, I need some inputs and parameters as well. I already talked about it a bit. So I need to select the forecast horizon. So this is at least one specific target year. I need to select the climate years to use and also the calendar years to use. There is also one option it's recommended to select here is the PCD adjusted climate option. So this tells the tool that it should use the latest PCD data for forecasting. This is in the database behind the DFT, so it will use those files. After I select these options, I click on validate, and I am able to, right now, I'm able to check the model summary. We will do it in the tool right away. So I will be able to see more parameters of the forecasting model it's just a summary, but I can check what kind of options I selected. And then this is the interface where I see the PMDB files as well. So at the forecasting step, I don't only simply forecast the load for new PCD data, but I also adjust my forecast based on the PMDB values I provided as input. So this is set here. So this adjustment is based on the PMDB file that we uploaded in the import section. And I already mentioned it that this is not the data-driven modeling step, but this is the so-called physics-aware step. So I'm sorry, but physics-aware step. Let's say physics-aware model. So these we have to fill out the PMDB file which you already may know that this PMDB file is about the heat pumps, the electric vehicles, um, additional loads, and also the rescaling values for given target demands. And so based on these values, the developers implemented this physics-aware model that convert these PMDB file values into electrical load values. So that's why we call it a physics-aware model, because these are based on simple relationships, simple assumptions about the processes or about the technologies that we talk about here. So this step will adjust our forecast. And after clicking around the forecast button, yeah, we will need to wait a bit. And then if the forecast finishes, I think this message will show up: forecasting task succeed. And then we arrive at the final forecast of our load time series. So I just do the same as on the slides, but I only choose one forecast year, one target year, one climate year. I set the calendar option same as of the forecasted year, which is 2023 in this case, and I click on this button to use the latest PCD values, and I click on validate. And after clicking on validate, I have a summary of the model. It's a bit more detailed than in the previous section, so I don't only see the regressors, but I can see the other parameters of the model as well, which I used. So you can see that for the irradiance feature, we selected 10 splines to use. So this is how you interpret these values here. And as we saw, the PMDB file is summarized here as well, but only for the selected target year. You can see the values of the PMDB file here. So EV, electric vehicles, heat pumps, you can check it. And if you see something strange, you can go back and change these values. And then the additional load part, and then other stuff. This is just made up numbers here, so I just would like to show you how it works. And then if I'm satisfied with this, I run forecasting. I click on run forecasting, and this will take some time. I hope it will be fast, so that we can see the results as well before the break. So any questions in the meantime, maybe? Anastasia, what do you think? Are there any questions which you couldn't answer or which I should also answer?
So there was a question from Michalis again, but I have answered. But if you also want to complement something, also Cyprus is a bit of a specific case, because as Michalis is saying in the last comment, there was a period of crisis. So yeah, they cannot provide the historical data for 2011 until 2015.
Yeah. So I think it's not a problem.
Data can be provided, but it would be pointless to use that data because there were abnormal drivers behind the demand.
Yeah, exactly.
Yeah, this is also why I use for the Hungarian node 2016 and 2018 for training. So these 3 years, because in previous years there were some external factors which I can't assess here in the tool. So so that's why I only chose the 3 years for training periods. I think it's not a problem. It's, yeah, of course, it's better. The more, the better for the tool to estimate the relationship between the features and the load. But it's still better to estimate a valid relationship instead of a fake one or a not anymore relevant one. So I think it's a good idea to use only 3 years for training in your case. Yeah. And 1 year for testing. Yeah, I agree.
There is one more question from Gonzalo.
Looking at the model evaluations, partial dependence plot for the month figures are different at the beginning and the end of the year, which surprises me. Why is this? I would have guessed that January and this were similar. Yeah. Yeah, I think I'm just thinking about it a bit. So yeah, this plot shows so yeah. I don't know. I'm not sure about this. I see that you don't have much difference between the effects of the month, but yeah, it's really it's a bit strange that especially the last 2 months are higher, or the last month is higher, the highest, and the first one is not. So yeah, the training period has some differences in this sense. You know, it starts with a January and then it ends with a December. So I think it can cause some differences. So maybe that's why it shouldn't be. Yeah, but yeah, you didn't say that it should be equal, but it should be similar. Yeah, that's true. So yeah, I don't know. We should inspect it a bit more closely, and also the topic of this feature partial dependence plots is scheduled, if we have time, is scheduled for Thursday. So we can dig a bit deeper in that, and maybe we can talk about it, and I can also experiment with this feature as well. But I guess we have to inspect how the features are selected for your model, whether this effect is only in this certain hour or in every hour of your model. So yeah, this is a delicate question. If I may, I would postpone it at a later point, maybe for Thursday.
Okay, we can leave it for Thursday.
It's okay. Yeah, thank you.
I just added the plot for hour 12 of the day, where we see similar problem, but there's more variation during the summer months. which I guess makes sense because 12 is hotter, so maybe
Yes.
there's more demand from cooling or whatever. But yeah, we can leave it for Thursday. Thank you.
Yeah, okay, thank you.
And there's also a question about the definition of demand that we're using in the training, but I think this will be covered later, right? In the slides.
Yeah, but I think we can talk about it. Yeah, maybe it should have been touched upon in the beginning. So yeah, we use demand and load interchangeably here. So it's power, it's electric power, it's the unit is megawatt, and because these are hourly time series, we just use load and demand for the time series, for the values of the hourly time series interchangeably, but these are megawatt. Unit is megawatt. So, but there is a case when you shouldn't think about power, but you should think about demand in the sense that for target demand, you in the PMDB file for the case of rescaling, you have to give the hourly consumption, electric consumption, so which is called target demand, which the unit is for that is yeah, terawatt hours, I think. So but it's just the sum of the hourly megawatts of the time series. And this is because of the hourly resolution of the time series which we talk about. So I don't know if I could answer the question. Okay. Michalis, just tell me if you need some more clarification on this. And now we see that the forecasting task succeeded. Yeah, we see the previous interface here, and then now we are able to go to the results section. Yeah, okay. There were some, yeah, I was a bit confused, but now it's okay. So in the first part, yeah, this is also in the presentation, but just go through it quickly. The results section. So I'm sorry, rescaling. Yeah, we will talk about it later. So reporting, which means results section. So after clicking on the results, go to results button, we can find the reporting functionalities and the visuals to check the results directly. So we have some report options. We will talk about them later. The reports look like this. So we have 4 of them. There is a global report, which is about the summary of the KPIs of the tool. So this looks like this. For each model, you have a different row. For this model, for one model, you only have 1 row, and you get some KPIs: max peak, average max peak, and average yearly demand. So this was done for 1 climate year. So this is the reason why max peak and average max peak is the same. Yeah. The next one is a so-called rescaling report, which contains the final demand forecast, the hourly demand forecast for all target years and all climate years. I think it's hourly. So this looks like this. these are Excel files if you click on the button. So this looks like this. So yeah, from row 4 and until row 8, you have some summary values. And from row 10, you have the hourly time series for each climate year, and every sheet and every target year is on a different sheet. We can check it later for our model, and we have the adjusted report, which is also hourly time series, but this contains all the effects of all the technologies which we inputted in the PMDB file. So it's not just the baseline forecast, which is called baseline forecast in column E, but the adjustment values are also listed here as columns for every hour. And the final forecast, I guess, but we will check it, will be on the last column as the sum of the baseline and all the adjustment technologies for every hour. So this is called the adjustment report. And then if we have a downloadable hourly time series from which we can download, and this is which I will show it in a minute. Sorry, but I will have 2 more minutes. I need 2 more minutes. So this is downloadable from the plot, from the visualization of the forecast. So you can see the global report here. You click the button, you get the first template, first report. You have the rescaling report here. Click the button, you get the rescaling report. You have an overview of some KPIs directly in the tool. So for this, we only have one climate year and one forecasted year. So we have a maximum peak and average maximum peak, but the 3%. So it's not the maximum, but it's the upper 3 percentile of the load, of the average of the upper 3 percentile of the loads. And then we have these demand values, which are aggregated demands, which are already in terawatt hours. And we also have an average yearly demand, which is an average hourly demand. So it's also called demand, but it's now power value. And this is a consumption value, the aggregated demand. And then you get more general information about the model. You have some more reports. You have the adjusted report here. And you see in the tool the summary of the adjustment components. So what's the average base load and what's the average effect of each of the technologies which you did. There are some strange values here. Yeah, it's just a made-up example. Don't we don't need to do anything about it. And then you have a plot which you can see. This is the whole year for 2023, the target year. You can change it here, and this is for 1 year, 1 target year and 1 climate year. And this is the baseline forecast. I just click out everything, and then you get the baseline forecast. You get the total expected value, which is the adjusted baseline forecast, the adjusted forecast with the effect of the batteries, the electric vehicles, the heat pumps, and the additional load. And then you get the 90%, the lower 10 percentile and the upper 10 percentile of the load forecast. So you get a range as well for every day. This plot also a daily plot. it's interactive, so you can zoom in. But this shows the average value for that specific day. But if you click on the hourly time series button, you get the hourly time series, and that's what you get from that button. So you get a CSV file with the values which are shown on the plot, and this will be an hourly resolution data. But in the tool, it's only the daily average that is shown. Sorry for clicking everywhere. And then I reset the zoom. And then last but not least, you get an overview of the temperature dependency. This is a key feature that we think that is a key feature, so it should be visualized as well in the forecasted year to get a sense of how it looks like for your market node. And that's it. This is the technical overview of the no, not that's it. So there is one more slide, sorry for that. So you can compare scenarios in the tool. There is a button for that in the results section up here. So you click on it and you select not just scenarios, it says compare scenarios, but you can select any kind of yearly forecasts. Now we have only 1 year, so it will show us the same plot, same values for each, for both of them. But if you select more climate years for the forecasting, you can select here different climate year and you compare right away the daily, also, or again, the daily average values of the forecasted time series for the given market node, scenario, forecasted year, and climate year. So this is a nice little feature. And that's it for the technical overview of the DFT. So now we saw a quick overview, just clicking through the DFT interface, and now we saw a more technical overview where we set up a complete project, a complete demand forecast. And after the break, if you don't have questions right now, after the break, we will get to more conceptual issues. Anastasia, what do you think? Shall we go on a break or just answer
let's
some
take
questions?
a break.
Yeah, okay. Okay, thank you.
And see you in 15 minutes.
Yeah, 11:30. Okay.
Perfect.
Thank you.
So did you say 15 minutes?
Yes.
Yes.
Okay, thank you.
Thank you. Hello. So if everyone is back, we can continue. Sorry?
Yeah, I think we can continue, right? Okay.
Okay.
So, yeah, I share my screen. So yeah, we finished, almost finished. I just realized that we have some technical slides still, but yeah, we can talk about it short. So we had an overview. We look at the workflow inside the tool, and then we created a whole iteration from a technical perspective, and we reached at demand forecast with the DFT. At the end of the slides, we have some technical slides still, but these are about formatting issues of the input files. So I think we can leave them for Thursday, maybe. And we can go on with the second demo, which is a more conceptual demo. And we will go through the same parts of the process again. And we discuss some conceptual issues and questions of each step of the workflow. So let's see. Previously, we saw that we said that the workflow consists of four main steps: importing, modeling, forecasting, and reporting. Now we can adjust this workflow. We already saw that there are lots of steps we can take, lots of decisions we should have to make in order to reach to a forecast. So now I would like to emphasize that the workflow looks like this. So it's the real workflow is more of this and then the simple one. So for every data collection, we will collect as sex or lex. We will collect some raw data. We will fill the input files with the specific values. I think about calendar files and the PMDB file especially. So we create these inputs, we upload them to the tool, we inspect these inputs, so to say, validate these inputs, and then we build our data-driven model, or more of them, from which we have to select one, which we do the forecast, and then we also inspect and validate the forecast which we have based on the model and also on the adjustments which are in the PMDB file. And then finally, if we are satisfied with the results, we generate the outputs, the so-called reports, we save them and we upload them or send them to ENTSO-E. So I think the real output, the real workflow resembles this 11 steps more than the simple 4-step workflow. And I created this figure about the workflow because I would like to emphasize that this demand forecasting process is most of the time is an iterative process. So we may iterate on the input data if we are not satisfied with that, or we have some errors. We also can iterate on the modeling step as well if we are not satisfied with the results of our model. And not just the results on the training sample and the test sample, but not just the data-driven model, but also the physics-aware model when the forecast adjustment takes place. So the modeling iteration can also happen. And yeah, if there are some issues still, as we have some issues or we don't like the results, there can be a whole iteration for the whole process. On the right hand side, you can see that how it looks like from the DFT's perspective. So as far as I understand, or as far as I do it, usually these steps are done locally on my computer, and the input data creation, and then also output saving and output sending to Anastasia or the data and models is also from my computer, so it's not possible to send it from DFT right now. And the DFT steps are the input validation, the model building, the forecasting, and the output generation. So I prefer to look at the workflow like this. What about the other issue, the more conceptual issues of the importing and the data-driven modeling? So with importing, I think we discussed the most important things. I saw that there are some technical issues, there are some missing files, there are some missing periods. So this will be, I think, this have to be discussed discretionally. So for each of you, we have to, or the developers have to solve your problems with the input files. But lots of times there are still some errors with the input files. We will have some recommendations for that later. But if you use the templates, normally you should be able to upload the input files into the DFT and then create the forecasts by your own. So what about data-driven modeling? We saw in the first part that we have to select training period and the test period. So the training period serves as a sample on which the model estimates the parameters, or the model is estimated, and the test period serves as an evaluation sample. So we can evaluate the forecasting performance of the model. Now, what other aspects we have for the training and test period? So why do we do this? Why do we split up the historical load time series, the samples, into training and test periods? So this is because we would like to evaluate how the model can predict the load on unseen data. So you can also, to extrapolate, temporally extrapolate the time series from a given training period. And also we would like to avoid overfitting. This means that we don't only want to have a model which fits the training sample well, but also we would like to have a model which fits the test sample well as well. So in this example, you see that this model is not that good in fitting the test period because there was a kind of structural change. The trend has changed in the time series, so our model doesn't take into account this information. So this overfitting can be assessed by the fact. So this overfitting occurs when the training sample errors are lower than the out of sample, the test sample errors are much lower. So if there's a big change, big difference between them, you should be suspicious that this is overfitting taking place. So how you see it in the tool. So when we did, it is the same example we did before. So when we created the model, we have some, we talked about it a bit. So we have the results section where we have a separate, we have a vertical line which separates the sample for the training period and the test period, and we can visually inspect how the model performs on the test period and on the training period. Also, we can see this, we can do this with the residuals as well. And the other possibility to check overfitting, this type of overfitting, I mean the difference between the training sample performance and the test sample performance can be obtained with the goodness of fit measures as well. So for every measure, we have a test value and a train value. So you see that the tool calculates these metrics for the training period and the test period as well. So if you have much difference in these values, then you have to be suspicious. So of course the question is how you assess it. So I think there's you have this automatically fitted best model, so it's a default model. So this is a good first step to choose, but besides that you should, or it's preferable to create another model as well. So you adjust this model somehow, make some changes and see how your adjusted model performs based on also this comparison. And if you see that the absolute values didn't grow too much, are not higher, but maybe the train versus test difference is smaller, then that's a sign of less overfitting. But it's, even if they are called, I call them objective metrics. So the model selection is not an objective task. So it's a subjective one. It's the responsibility of the modeler. So yeah, we should compare more models. We should compare more metrics, and we can assess. This is how we can assess overfitting. We will talk about the other metrics, the CV metrics also as well, at a later point. So for now, for the time being, regarding overfitting, you can visually check it, or you can check these metrics, how they differ. So this is about the data-driven modeling part. So we talked about what we can select here, and yeah, we talked about the different types of models which are implemented in the tool. So if I choose a new model here. No, why don't I? I'm not able to choose one model here. Don't know why. Okay. Let's start from start again. So yeah, let's do it like this. So I create a new model for the same inputs. And I can create a new model, but I can also import an existing model. So I select the same automatically best fitted model. But now I change the title. So let's test one. Yeah. So I get the same values than before for the default model, but I can change them of course. Now I would like to change maybe, I don't know. So the topic here is the model types. Oh yeah, we can I think have a random forest model for the time being. So the random forest model is different than the generalized additive model. The first difference is that I cannot select model per hour here. So it's always a single model for the random forest. It's not possible for this model in this tool to be an hourly model, a different model for each hour of the day. So, but otherwise I don't change much. I just leave it like this and save it. And I run the modeling in the background. So, but just to talk about a little bit about the model types. So linear regression is lasso regression is more or less the same. Lasso means regularized regression. This makes some parameters, this restricts some parameters. So with this restriction, parameter restriction, this lasso regression wants to tackle overfitting. So even if in a linear regression, all of the features which I selected will be used with a certain parameter, and the model will estimate a certain parameter for all the features for all the regressors in the model. This estimation may be a bit. So after the estimation, the model can easily overfit the values here, but with lasso regression, we restrict some parameters in the model based on an objective function, and the parameters will be restricted, which results in regulated regression, and this tries to avoid overfitting. What about random forest and GAM? So random forest and GAM are non-parametric models that can explore different nonlinear possibilities for the relationships between the explained and the explanatory variables. So the load, the electrical load values, and the explanatory variables. And yeah, their algorithm also wants to minimize the errors between the adjusted, so the estimated values and the observed historical values. So I just copied two figures here for you to get a sense of how these models differ, how these models work. So this is the GAM model. The GAM model consists of, for a given regressor, which is on the x-axis, and for a given y value, which is on the y-axis, it creates a function. nonlinear function of the x values. So it Tom, I think you are I can hear you. If you have a question, just give it a go if you want. Maybe it's not the same purpose. So this creates a flexible relationship between the specific feature and the load. And this is additive, the generalized additive model, because it adds up all the effects of all the features to get the load. And also for one feature, it creates this flexible functional relationship out of simple functions of the data. This DFT uses the cubic splines to create this flexible function for each of the features, between each of the features and the load. So you can see in the background that these are these flexible splines. So this is how it adds up each component, and the effect of each feature is then accumulated to get the real load. And then random forest is a bit different. So random forest, we can imagine random forest as a decision tree. It splits up the problem into easier decision trees, and then it creates lots of these decision trees. Every main branch here is one decision tree, where it splits the problem into smaller pieces. And out of these lots of decision trees, let's say, it will create an average. So this average will be the estimate of the random forest for a given input. And as you can see here, these are the. I'm also not a mathematician, so I just have a a picture of how these models work and how the developers, what kind of algorithms they used. So, but I think you can imagine how these work more or less, and it's quite important because we have the option to set some hyperparameters for each of these model types. So for GAM, we can give the number of splines which the algorithm uses to capture the relationship between a certain feature and the load. And for random forest, we can set, and we can see it here, we can set the number of estimators and the maximum depths of the trees. So here, number of estimators is if I'm not wrong, I think it's the number of separate decision trees which the algorithm runs in parallel, and the maximum depth refers to the depths of each of the decision trees, and yeah, you can set these parameters, and of course, if you use more trees, you get more values to average over after an iteration, and if you use more deeper trees, you get more fine, let's say fine results. So you get a more sophisticated model, let's say. So So this is how you should interpret these parameters. I just left them as it is, as the default. So I don't, yeah, we will have some recommendations. I think it will be on Thursday. So how you should tackle a demand forecasting problem and how you should, especially this data-driven modeling part, how you should think about it and how you should adjust these values. We don't go into too much details regarding these hyperparameters. We can only say that we only say at this point that overfitting can happen easily, and for each of the model types, of course, if you use more splines, you get a more flexible function or relationship between certain features, and if you use more depths of each trees, you get more fine values, and you are maybe overfitting the training sample that way. So we only, as a recommendation, we only give a warning to you that because this is only what we get, we also don't have an objective answer for these problems. So please make sure you don't overfit and adjust these parameters accordingly. But that's why I said that it can be an iterative process, this model building step as well. But also that's why I just cover it as a conceptual process, iteration, and during the technical iteration I try to avoid going into details. So now the modeling task succeeded in the meantime, so we can check how this random forest model behaves. So now I just would like to have a quick overview of what we see. So now you see that, maybe you don't see it because it's not have enough resolution. So you can see that the relationship between a certain feature and the load is quite detailed, let's say. So it's the model, this random forest model with the default settings, tries to, so imagine that behind these functions, behind these curves in the background, there are points. So there are data. So this is a curve which best fits the data behind. So the model with these much parameters, with these parameter settings, depths and estimators, yeah, so it certainly overfits the data. Even if we don't see the points behind, but we see that the wind speed relationship between load and wind speed shouldn't be this detailed. So it's irradiance, but maybe, yeah, I want to select temperature. Irradiance is also quite, they are not smooth. So yeah, this is how it is. But you still see that we, at least as a visual inspection, we see that the fit is not bad. But now we see a bit different result with the residuals. So now we see that the training period has much less errors than the test period. So this is a sign of overfitting, as we discussed before. And we have the goodness of fit measures as well. We can compare them between the test and the train results. And if I'm lucky enough, I can. So basically, it works like you can do it at once during one data-driven modeling step to create more models. Now it didn't work for me. So let's try to. Okay. I don't want to log in again. Maybe let's try to check the other one. This is the second trial, I think. And previously we had a model for. No, I don't know how to. This is the test model with the random forest already. Yeah, I know how to do that. So yeah, this is also a feature which we will cover later. But even if you start a new task inside the project, I just did it before to create a new model. You have a button, an option to access the history. This is true for every step in the process. So for imports, for data-driven modeling, for forecasting as well, we will be able to access the history. So now the current version is the random forest version, but if I activate here the previous one, I get back the automatically fitted best model. And now I get to see the results of that. Hopefully the other sheet will not change as well. Let's try to do it like this. This is, yeah. So now we are able to compare them. It's not the best version. We should see them under each other, but we did the same. So what we can see here, this was the automatically fitted best model, the previous one, the GAM model. This is the GAM model. So let's check RMSE and for training and RMSE for tests. You can see that 130, 160. Now with the random forest, for training we have a lower one, but for the test set we have a higher one value. So it means that for the training period, the random forest performs well, performs better than the GAM model, but it clearly overfits and the test results are much worse than for the train results and also compared to the GAM model. So this is how we can assess that overfitting is more serious here and during the second model, at least for the RMSE, and also for we saw it visually for the residuals. What does the other metrics show us? So we have MAPE. We will talk about what they are soon. So the same picture, right? 1823, 1428. So the message is the same. We have overfitting in this second case, and yeah, the same for the 3P test and train values. So overall, I prefer the GAM model here because it doesn't overfit that much, and the test values are lower. Yeah. So it could be a kind of an easy choice if we need to choose between these two models. If we base our decision on metrics and on overfitting, but of course there are some other aspects as well. We will talk about it later, maybe on Thursday, but you can all that's why, yeah, this is the reason why you can assess the partial dependence plots here, is that you can also make a decision or adjust your decision based on the estimated relationship between the features and the load. So if you have a really good model which, yeah, performs well on the training and on the test set as well, but you see that the relationship between maybe the temperature and the load is not what you would like to see, because, yeah, the model did something strange during the estimation of this relationship, then of course you can adjust your decision, and you can still fine-tuning your model. In the end, of course, during this demand forecasting task, we need to provide I don't know, let's say a precise forecast for the demand. But yeah, precision is like kind of subjective in this case, as we saw earlier as well. And maybe we prefer more that we have a good model which describes the reality more or better. So this is just a side note on how to select the models. And with this example, we saw that the random forest and the GAM model with the default settings can produce different results, and random forests with these hyperparameters are clearly overfitting the data, at least more overfitting more than the GAM model with the default values. Yeah, so this was the part of the model types. I don't know, any questions at this point which I should answer or we should discuss? Yeah, I think the documentation. Anastasia, can you say a few words about it? I think it's
Yes,
important.
so we are going to share with you the documentation. It's just that it was under improvement. But in any case, if you have any more questions about the tool and the modeling and how it's working, please, you can refer to us whenever, or to the developers, but probably better to us first, unless there is something, a technical question that we cannot provide you answer with. But we can, of course, intervene and communicate with the developers and answer to you as fast as possible.
Yeah, so there is a documentation which is under improvement. So that's why we don't have the link right now, I think, the final link.
Exactly, yes.
But we will have it, I guess, yeah, as soon as possible. So, and in the documentation, there will be some more details about the parameters and the maybe also the explanation of the parameters as well. But just keep in mind that this is not, I mean, there are, as you can see, there are some topics which are more, let's say, advanced. I also have I just have an overview, a sense of how these things work, and lots of things I have to iterate and experiment with the tool if I want to fine tune something. So yeah, just to keep in mind that the documentation will be also like, yeah, you get some answer, but for your specific task, you may experiment with the tool and experiment with a little bit to get to a satisfying result and demand forecast. Okay, so yeah, welcome.
You're welcome.
So yeah, the next thing is this option between hourly models and the hour model, the hour variable as an explanatory variable. So in the tool, I'm sorry, I just clicking on there. Yeah, in the tool we saw that yeah, we definitely need to address this issue that I cannot create a new model here. So whatever. So if we go back to this GAM model, yeah, you see here that there is an option called model per hour. So this is true for this is available for the GAM model and for the regression models, I think. So the model per hour, what does it mean? So this means that if it's on, this option is turned on, then the GAM model will estimate 24 different models for each hour of the day. If it's off, it's just one single model for the whole sample for the whole time series, and this doesn't separate between the hour of the day. But in this case, you still have an option to incorporate kind of hour of day effect in the model. By selecting the hour as an explanatory variable. So in this case, this will be a feature. So for every different value of this feature, I mean the different 1 to 24, it will have a different impact on the load. So this will serve as kind of the same as a different model for every hour, but this will be estimated together with all the other parameters in the model, while in this case, these models will be separate during the estimation, so they are estimated separately. So yeah, this means that both options should produce similar results, but of course the results should be checked and there can be differences. If you have hourly models, so if you have this option turned on, then you are able to see the partial dependence plots for each hour independently. So that's what Gonzalo, I think, showed us. So he had a model for every hour, so that's why he was able to see the relationship between whether the features and the load in every hour. This is the case here as well for the GAM model, that we can choose the hour and we can estimate, we can visualize the relationship between the feature and the load values, the load itself. About this feature, about this partial dependence plot, we will talk about it later, I think on Thursday. So we will have some warnings about it, how to interpret it, is because you have to be a bit careful about how you interpret the values here and the plot itself, but it's certainly a useful tool for model validation. SIA partners, the developers of the tool, suggest that we should use the hourly models all the time when we are able to. So for the GAM models especially, because they say that this will allow us more precise estimation of the relationships between features and the load. Also, maybe the predictions will be more precise, but yeah, of course, this also, the overfitting issue can also happen here, because and also, yeah, if we set the hourly model option true, then we will have a lower, a smaller training sample for every model, because we will have 24 different models, each for 1 hour, day of the hour, 1 hour of the day. So we will have much less data behind each of the models. So yeah, there was another option, this confidence interval, and you could select the features inside the tool. What's next? So what about the variable selection? How you should select what types of weather features and kind of features we have. So we should talk about a bit about the temperature. So in the tool, there is a raw temperature data from the PCD, and there is also a smoothed temperature data, which is kind of a smoothed average of the raw data. This is because the smoothing was done by the developers, because of the fact that there is a medium-term effect of temperature on demand. So, so for a specific demand for a specific hour, it's not the temperature of that specific hour which is the most important most of the time, but it's more of a so there is inertia in that. So the previous hours, the previous temperatures also have an effect on the load. So that's why they suggest to use that and experiment with this feature as well. What does population? How is it called? Sorry. Population weighted temperature. Yeah, what does it mean? So this means that the PCD values are calculated by the developers of the PCD database by weighting the national temperatures, or the temperatures of each locations by their population. So it is closer to the load itself. So there is the closer relationship between this population weighted temperature and the load versus the simple measured temperatures versus the load. What about the wind speed? So wind speed, yeah, you know, it's doesn't have strong seasonal patterns. It's quite volatile. It can be, and yeah, these are the effects which can be assessed about wind. Lower the perceived temperature, accelerates heat transfer. So for demand forecasting, wind speed can be useful, but it's not the most this is my experience, that it's not the most important feature, but it can have certain, especially in certain periods, it can have a effect on on electrical load. So it's advised to incorporate it, to use it in the models, but yeah, make sure that you don't overfit. You don't overfit on wind speed, because it's not the most important feature. So overfitting shouldn't take place with this feature. Irradiance, yeah, irradiance has has a high correlation with temperature, of course. It's also included in the database, so we can use it. Yeah, this has some effects, additional effects than temperature as well, and also the interaction can be maybe interesting. So if you incorporate it, yeah, you can also check it. You should also check it, how it behaves, and if there is something wrong, yeah, you should adjust some parameters or even try a model without this feature as well. It's yeah, for each case it can depend. It can differ. So what about the calendar features? So calendar features are like the types of days. We call them calendar features. The type of day features normally. So by default, DFT includes the weekdays and weekends. And with the calendar file, we can incorporate the effect of special days into the models. So yeah, you have to keep in mind, we will talk about it, the calendar file itself, if it's not familiar for you. So the calendar file, which serves as a file database for the special days for your node, should only include the special days and not categorization of the weekdays and weekends, because these are already inside or implemented in the tool. So yeah, what kind of days we can talk about as special days, holidays, bridge days, some days after holidays or before holidays. In Portugal, it was done by our Portuguese colleague. So in Portugal, August is also a special month for electrical demand. And also Christmas period, Easter period, and certain city holidays, the holidays of big cities, can have an impact, and they can all be implemented in the model through this calendar file. We will talk about how it looks like. And yeah, ideally, yeah, this is also the case with some other things, but here for the calendar days, calendar information, it's also true that it's best to analyze it previously, because the tool, the DFT, doesn't give you easy analysis functionalities for these effects. Of course, you can experiment it. You include only holidays, you include holidays and bridge days, you combine them, you do something else, so you can incorporate a different combination of these holidays in the tool, and you evaluate the results of these, of these different combinations. But it's best to have a knowledge of how the special days affect your load. Yeah, and of course, yeah, there are no defaults here, so in the tool, so you should create your own calendar file. So that's why I say it's best to have some previous analysis or some previous knowledge about it. But it's not that difficult. So of course, for I guess every market node, holidays, bridge days, and Christmas period, if it's relevant. So these can be known. These are known as special days. Yeah, you can see some examples here. So the impact of calendar of holidays is really important. For a Monday, it's especially, and for Thursday also especially in this example. But for a Sunday, it's not that important because Sundays maybe are similar to holidays. And yeah, just a message again that these are really important features explaining demand behavior. Yeah, there was a question, I think, about these timestamp values. So here we are.
Before we move, can I ask some questions on the calendar file?
Yeah.
Yes, the previous one that was using Trabunda, I have no idea how it was created and who created it. Was it possible to find out who created it and how?
Yeah.
There were special days for the entire summer, basically. Summer weekday, summer weekend. From what you have shown us, I suppose this is wrong. Because whether it's weekend or weekday, it's already taken into account by the DFT.
Yeah, no, it's not wrong. It's just, let me rephrase it. Maybe, so, yeah, you don't need to indicate in the calendar file that a day is a weekday or the day is a weekend because the tool
Or
knows
that
it.
do you need to indicate that it's a summer weekday or summer weekend?
If you think it's relevant.
I can
Yeah.
understand that you would need to indicate August because, like you, it's Cyprus, everything closes for 2 or 3 weeks in August. So suddenly you see a dip which is not what
Yeah.
you would expect based on the temperature, and then it comes back up again. So that period, I can understand that you would need to indicate it as
Yeah.
a special day, but would you indicate as a special day the whole of the summer, basically, June to September?
Yeah, I don't know. Yeah, it depends on the market node. It depends on the load, how it behaves in these periods. So you should decide. You have to decide. So that's a pity. But there is no one solution for that, which fits all market nodes. If you think, just one more remark, if you think you need to define a special day category for every weekday during the summer, you just create a column in this file. I guess you are familiar with the format because it's the same.
The question is whether this is correct or not. To me, from my understanding of how the forecasting tool works, it's wrong, because then you don't let the tool itself to do the correlation with the temperatures.
Yeah, I just rephrase it somehow. So the tool will estimate a different effect on these days. It's also between the temperature and the load, and yeah, it will get a different effect. It will get a shift for, if you think about the easiest model, so it will get a shift, which you said. If you see a dip which is not cannot be explained by the temperature values, then this dip should be can be captured by this special day category. And so this is not wrong in the sense that the tool will be able to assess a normal weekday effect and a normal weekend effect. But during this period, the effect will be different because it will get an additional special day effect in this sense. So it's not wrong. If you think it's relevant and this is an effect that cannot be explained by weather conditions or other things, you should try to incorporate it, and then check the results, and if everything looks right, So normal weekdays look good, normal weekends look good, but also the summer weekdays look good and the summer weekends look good, then I think it can be good. But it's not wrong in a technical sense. It's a conceptual issue, and you have to check the results of the model after this if you incorporate this effect.
Well,
What do you think?
I already expressed my thoughts. Now, I'm not a demand forecaster. My understanding of how these things work is limited. I can only do what I understand. If more investigation is needed, I would need the assistance of the central team. But from what you have just explained, to me, it appears it doesn't seem right to mark the entire summer basically as a special day. If it's the entire season, then it's no longer special. I suppose another question: how many types of special days is it typical for people to define in order for this to work properly, but not to be overfitted?
Yeah, I think you should keep it as low as possible. But
the way I suggested it in recently, but I don't know if it's the right one. It would be to have one type for the August holidays, one type for the bank holidays. Now, from what we have talked about, perhaps a third type could be introduced for bridge days, as you have called it.
Yeah.
But beyond that, it would be an overkill.
Yes,
that's
of course.
my thought.
Yeah, of course. It's not a rule to use them, so it's just a set of it's the possibilities which these are the special days that we can call special days. And I also suggest, this is also listed here, I think. Not here, but somewhere here there is a suggestion. So yeah, similar days should be in the same group. So only use a justified number of groups. So for me, this is my personal suggestion. Only use 2 to 5 different groups. So yeah, as you said, one for bank holidays, one for, I don't know, bridge days, and one for special months or special periods during the year where there is no school or something like that. But and even if you identify more than one group, more than, I don't know, 3 groups or more than 4 groups, five groups which are different, you should also like just group them into one single group and then use it like that. So this is our suggestion, as you said. So I agree that it's an overkill and it's overfitting and it cannot use many data as a sample if you. So it will be a restricted sample and the estimation will be not well-founded, let's say, if you use more than the justified number of groups. Yeah, I agree. So for your case, I don't know. That's why I didn't want to answer specifically. It sounds to me an overkill to indicate the whole summer, because of course also, that's what you said, I think, or implied, that there is a month's calendar feature as well in the tool. So this creates different. So this results in different effects or different load values for each month. So this can represent some of this seasonality, kind of. Also the day of year. This is also yearly seasonality, which is not explained by monthly and day of week seasonalities. So this can also be incorporated in the tool. So I agree that if we shouldn't use seasonal we shouldn't include seasonal patterns into the special day file. I agree. Yeah, that I think can be a message. If this is what you refer to as well.
Basically, yes.
Yeah. Okay. Thank you. Yeah. That's true. I agree.
I know from previous experience with the previous members of the team that the holiday file did cause trouble because I remember one year Hubert removed the holiday file entirely, and that cleared some weird random spikes in the profile.
Yeah. Yeah. So yeah, the ENTSO-E would like you to create the forecasts yourselves. I mean all the market nodes, the SACs. So this also includes the creation of the calendar file. And I agree that it's really important to have a good calendar file. Also a good format and a good content. So yeah, we talked about the content a little bit, but we can talk about the structure as well, the formatting, which we will cover on Thursday in more depth, I think. But yeah, it's you have to keep in mind that calendar file should be correct in both sense. Yeah. Now we won't eliminate it, so it will be you who use it or not use it, decide. But yeah, just keep it simple in the beginning, and if the results are good, then it's fine, I think. Yeah, so this is calendar seasonality, which I talked about a bit. So month is kind of a seasonal pattern, and also day of the year is also a seasonal yearly pattern. Sorry. And then these timestamp features. So these three are supposed to capture long-term evolution of the load. So that the yearly seasonality and the weekly seasonality can be captured by certain features. So across the year, longer term trends are not covered by these features. So if you think that in your historical load time series there is a linear trend, or there is a trend, the temporal trend, you can check, you can incorporate them by clicking on these variables. They are different, but they want to have the same trend. They want to represent the same this long-term trend in a in a similar way. So they are not exactly the same, but they are similar. So I guess they should also be used with care to avoid overfitting. So it's not necessary to include all of them, but maybe it's enough to include the monthly at first, which is the simplest one. So it will create a value or a variable which differs in every month. So it will be the same for every hour of a certain month, the value of it. And if it's not enough and the time trend is not good, you can experiment with these features. But yeah, these are not the most important ones, I guess. But certainly, if you think that there is a historical trend linear, more or less linear trend in your time series, you should at least include at least one of them. This is also true if you think that the 2023 values, I mean the present load values, are no, okay. So I don't say it because that's not true. But what I wanted to say. So I think it's important that if in the past there was a trend, you include one of them at least and experiment how it looks like. Important that the values of these features are not extrapolated, but they are fixed at their last value. So the developers wanted to avoid that this value explodes in the long term. So this trend is not extrapolated in the forecast. It's not. It doesn't have an effect actually. But for the historical model, the data-driven model, if there is a trend like that, it's important to include because in that way the estimation of the other features, the relationships between the temperature, the other calendar effects, will be much more precise if we include this as well. So if there is a trend in the historical time series, and if we include one of these features, then the historical trend doesn't need to be estimated or soaked up by other features. So other features will be more precise. They will more precisely show the effect of the feature which they represent. So I don't know if it's understandable, but if there is a long-term trend in the historical time series in the training sample, you should include one of them. Yeah, it was a bit long explanation, but I hope it was more or less understandable. Yeah, we talked about these hyperparameters of the GAM and the random forests. I don't want to talk about it more now. So yeah, we have some, sorry for being a bit, yeah. Okay, so we have some more slides and we have 15 minutes left. I don't know, shall we do a Q&A now? Anastasia, what do you think? Because we have
yes,
some
maybe.
more issues here, but yeah.
And we can continue with the rest on Thursday.
Yeah. Okay, let's do it like that. So yeah, feel free to have some questions. Yeah, yeah, I can answer this question maybe, this timestamp question. So yeah, it's true. It's a good point. But yeah, as I said, the timestamp features are for capturing the trend, the long-term trend, while the calendar file for the special days are capturing the effect of special days, which are the same in every year. So these serves as a different kind of calendar feature. The feature or the calendar effect, which is across years, which is a longer term effect. So yeah, calendar file shouldn't be used as a and cannot be used actually. Cannot be used as a long-term trend capturing feature. Any other questions? This is the content. This is how this is where we are. We almost finished the conceptual demonstration, but we didn't have a separate DFT model prepared for that. Maybe it's not that important. During yeah. Can have
Sorry,
it.
yeah, maybe one short question. On the model per hour,
Yeah.
the GAM models, or what does explanatory variable mean? Is it like a regressor? Is it the same thing, or
Yeah,
when the model per hour is off, then it means that the hour becomes a
it's not.
regressor?
No, it's
Or...
not automatically. So yeah, hourly model vs vs single model. This is more precise, I think. And for a single model, you can add the hour variable as an explanatory variable. So it's not automatically included in the model, in the single model, but it's an option for you.
But also, so then explanatory variable means the same thing as regressor. Like then the hour would have the same
Yes.
role as the radians and the wind speed and the population body
Yes.
temperature and so on. Okay.
Yeah. Yeah. It says it like it here. Yeah, we can select hour as an explanatory variable.
Mm-hmm.
Yeah, you can call it regressor as well. Yeah. So yeah, we interchangeably use explanatory variable, regressor, and feature.
Okay.
So this is because of the regression has regressors, but the machine learning algorithms have features. They call it features. So GAMs and random forests, for them, yeah, feature is a better term. So yeah, that's why we use it interchangeably.
Okay. Thank you.
Welcome. So
Okay, so if there are no more questions, maybe we can close it now for today.
yeah, Anastasia, can we, are we able to collect these questions which we didn't cover, maybe, or not yet? Are there
Yes,
any?
although most of them are covered, then, apart from the ones that are in the presentation, I think. But
so after, just
yeah, I have been giving access to everyone. So
yeah, okay. Well, I'm not referring this specific question. I'm just curious whether we close the session, the meeting. Can we access these questions after that?
yes.
Okay. Okay. So we don't
Yes,
lose
yes.
any questions from here. And then, okay, I just wrote down the problem of Gonzalo with this.
Yeah, so if you have any problems with or if you have detected something going wrong with your country files, let us know by email. But in any case, we will deal with this issue during the workshop week that you have registered for, and we will run the forecast.
Yeah, and I think, if you can have a look at the tool during the next one day,
Yeah, exactly.
so on Wednesday or on Thursday, yeah, during the training, so it can be useful. And then if you have some questions, you can still ask on Thursday, and we try to cover them. And then, yeah, as Anastasia said, during the workshops, you are expected to create forecasts, so during that week. And yeah, you will have some assistance during that week. I don't know the exact structure format of that week, but I guess we will
So we
figure
have
it out.
4 weeks during July. You're still welcome to register if you haven't done so, although most of the TSOs have registered. And yeah, feel free to experiment during these 2 days until Thursday, and we can deal with your questions or queries on Thursday during the training.
Okay.
There's a question from Michali, or yeah, Gonzalo.
No, I
Yes,
was just going to say thank you very much. So,
Okay.
yes, I would like the exact definition of the demand that this tool needs as an input for the historical loads and as a target for the forecast. In our case, we do our forecasting based on generation forecast. And I don't know where you have obtained all the historical data that is on the database, but my guess would be that it reflects total generation. It probably includes an estimate of distributed generation. If this is not what it should be, it's perhaps a good opportunity to try. Not for all the historical years you have in there because they are not useful. But if we will be redoing also calendar files, it's perhaps worthwhile, at least for the years that we will use to try and make sure that all the inputs are as they should be. It could be time consuming to do this because our systems are, they can give you total generation easily, but if you want to obtain something else, you have to obtain many different things and calculate it yourself. And sometimes the system breaks down when you have to go, when you try to go far into the past.
Yeah, shall I answer, Anastasia?
Yes, yes.
Yeah, so yeah, it's a delicate question, and it's a really good question. I think we will cover it on Thursday, definitely, but yeah, we should talk about it a bit. So indeed, it's really important that the demand is the historical demand is what we need, or what ENTSO-E needs. So I think we can define it, and we try to define it in a way which I hope understandable. So these forecasts for summer, so seasonal outlooks are inputs of a market simulation. So yeah, this emphasizes the PVs. So if the PVs are included in your PMDB renewable file, so there are so if they are in there, they will be used as generation. So okay, no, and I know I started from a different perspective. Sorry. So what Michalis said. So demand is, I think demand should be, this is a first rule, demand should be actual demand, and it shouldn't be adjusted or contaminated or uh, adjusted by distributed generation. So I think for the market simulations, they need the actual demand. So if you have actual demand, actual estimated demand, so this is the best estimate for for demand for your market node, then it's okay, I think.
So, but then how will you estimate total demand if you don't include an estimate of distributed generation? Because the only measurements that we have as a TSO are at the transmission level. And
Yeah, I
now,
know. I know.
Yeah.
I know. But yeah, you have options here. So, but that's why we started here with the market simulation. So, in a market simulation, generation and demand has to be so no generation and no demand should be double counted, but every generation and every demand has to be included. So you have to make sure that you have coherent values in your demand load file and in your PMDB renewables file, for instance. So if your load time series include, so if you have rooftop PVs, for example, in your market node, which is, so if you have rooftop PVs, so if you include these rooftop PVs in PMDB renewables file, then in the market simulation, they will use them as generation. But in the meantime, if you have the demand time series and the demand forecasts, which also include this the effect of rooftop PV generation. I mean the load, the measured load is lower because of these local generators. Then you you have to adjust one side, either the demand side or the generation side. So if you know that your load file or load data contains the effect of rooftop PVs, then you shouldn't include them in the PMDB renewables file because this is already taken into account in the demand file. But also there's another option. You include them as a generation, as generators in the renewables file, and you adjust the load, historical and the forecasted load with these values, with the generation of them. I know it's not measured, but you can estimate it somehow. I think this second option is preferable because, yeah, it's good to have generation in the market simulation on one side and demand on the other side, and they are separated. This is now the case, I think. So I don't know if it was understandable.
To be honest, I'm more confused now.
Yeah, okay.
Well,
Sorry for that.
to put it as an example, over the last few years, the peak demand that we measure on the transmission system is constant. The peak in the summer, but the total demand of the system is increasing. It's increasing at about the same rate as the additional generation that you get from PVs at the time of the peak the demand. So when at least when we do our forecasting, it's we take into account the total demand, including the demand that is covered by distributed PVs. And the forecast that we give is the total is essentially the total generation that you need to have.
To cover
So
demand,
so the total forecast that we use, it also includes the auxiliary power of the power stations. Yes, even yes.
So
now
you do just to understand. So you don't only use the measured demand. Yeah, okay. Measurement is it's a different
what
topic,
we
but
measure, what we normally measure is not, or at least we can obtain, all the offtakes from the system, but that's not readily available. I have to do it manually. What we normally measure is the total infeeds to the transmission system.
yeah, which contains this lowering effect of these local generators.
Yes, yes,
Yeah.
yes. So yes, and
So
it's a
but you
total.
adjust,
It's
but
actually total generation that we measure on the transmission system. So
yeah, I know.
it includes the auxiliaries.
Yeah, but somehow, do you do something with this total generation, including auxiliaries? So do you do something manually, you say it, manually before inputting into the demand forecasts? Do you do something with this time series?
I don't know. We don't have demand time series internally for
Yeah,
forecasts.
but
I'm asking you
for
what
yeah,
I
but
need to do for this tool.
you have a load file imported in DFT. So ENTSO-E has a load file from you.
No one seems to know, neither from ENTSO-E nor from our side, when that was generated, how it was generated, by
Mhm.
whom, what it
Yeah,
contains.
yeah,
My guess is that it's the total megawatt generated at every instant, including an estimate of the distributed generation. In terms of the timings, I don't know whether it's local time or whether it's UTC time.
yeah. But yeah, so if it this is the case, I think it's not bad. It's quite good that you try to so you have a load file which contains all the demand, but
All the generation.
all the generation. Yeah,
Including an estimate of distributed generation.
but you said that peaks are constant. So is it constant in
As,
historical time series as well? I mean, in the data
uh,
until 19.
I don't know. I don't have it in front of me.
So
Uh,
you say that it's the case in the last few years, maybe?
well, from what I remember, I checked 2017 to 2019 at some point,
Hmm.
and what I had discovered was that it didn't include an estimate of the PV generation, but it was given in a local time, not UTC time.
Ah, okay.
But I think that we're using UTC, right?
But at some point, I checked this years from what
Yep.
I remember with
We
Hubert. I did a
yeah
correction just for those years.
we need the tool needs
Anyway,
UTC timestamps, and the tool in that's what
I
we
think
just
I
talked
think
about.
I think rather than trying to guess what someone did in the past, which might have been done for a different purpose, because that load file might have been provided from before Trabunda for
Yeah,
a different purpose when it wasn't as important. Perhaps it's best to be amongst us clear what it is that we need in order to do a correct job, and then decide which years we are going to use, and work from scratch just for those years. And then we know that what we have for the years that matter is correct to begin with.
yeah, I agree. So I also agree that we can discuss it
Perhaps
in a
after
separate
this
call.
meeting, you can send me a clear definition of what it is that you need. Perhaps I can also send you an email to tell you what it is that I think that we have
Sure.
that you have in those files, what it is that we can easily obtain, and we can probably obtain anything that you need, but there are things that they are there